Hello everyone, this is our session 20 on differentiation. We had completed higher order derivatives explanation and successive differentiation of standard functions. One of the functions, that is x raised to n, was done. Okay, let's move on to exercise 1.5. The first four questions are regarding the higher order derivatives and the last question is about standard functions. Okay, so let us begin. Exercise 1.5. Okay, question 1. I'm doing the fourth one. The initial ones are simple. They're just the polynomials which you have to differentiate twice. Okay, so I'm taking the function y equal to x cube log x. Okay, now we have to find d2y by dx square. So first let's differentiate with respect to x. Okay, so dy by dx is equal to first term as it is, derivative of the second, plus second term as it is, derivative of the first. Okay, so this will be x cancels out, so x square plus 3x square log x. Okay, this is dy by dx. Now this is your dy by dx. Let us differentiate one more time, that is we have to find the second order derivative. So we'll differentiate it once more. So d2y by dx square is equal to d by dx of, and in the bracket you will have x square plus 3x square log x. Okay, now let us differentiate this. So d by dx of x square is 2x plus first term as it is, derivative of the second, right, plus second term as it is, log x, derivative of the first will be 6x. Okay, so what will we get? 2x plus 3x plus 6x log x. Okay, so we have 5x plus 6x log x. So in this we can take x common. So d2y by dx square is equal to x common 5 plus 6 log x, right? So this is our d2y by dx square, correct? Now let us move to the next sum. I'm doing the sixth one now. Okay, so the sixth sum. Yes, what is the sixth sum? It is y equal to x raised to x. Okay, so normally when we have x raised to x, we take logs. So taking logs on both sides, so log y is equal to x log x. Okay, differentiate with respect to x. So what do we get? 1 upon y dy by dx equal to first term as it is, derivative of the second, plus second term as it is, derivative of the first. So we are left with 1 plus, or y into 1 plus log x. Okay, so dy by dx is equal to x raised to x 1 plus log x, correct? Now what do we do next? We have to take d2y by dx square. So let's change this. d2y by dx square is equal to d by dx of, and in the bracket you put x raised to x 1 plus log x. Okay, now this is like multiplication terms only. So what we'll do is first term as it is, derivative of the second 1 is 0 plus log x derivative is 1 upon x plus 1 plus log x as it is. And what is the derivative of x raised to x? Now x raised to x derivative we found out was y into 1 plus log x, that is x raised to x 1 plus log x, right? So we'll take x raised to x and 1 plus log x, right? Yes. So what is the answer? X raised to x minus 1 plus x raised to x 1 plus log x the whole square. Okay, this is d2y by dx square, right? So this is your sixth sum. Only one step, I have just directly written the derivative of x raised to x. See, here we have found out on the left side in black, we found out what is x raised to x derivative. It is x raised to x 1 plus log x. I directly substituted that as x raised to x 1 plus log x. You can write over there from 1. We can mark this as 1 and we can say from equation 1. Yes, so this is question 6. Here we complete with the first part. Okay, let's move on to the next one, question 2. So the question 2 says find the second order derivative or d2y by dx square. So I'm taking question 2, the second one. Here we have parametric functions. Okay, so let us begin question 2. I'm taking the second part in this. Okay, second one. So we have x is equal to 80 square and 280 square and y equal to 480. Okay, now they say that find d2y by dx square. So first we have to find out dy by dx. Now by theorem on parametric functions, dy by dx will be equal to dy by dt, right, upon dx by dt, right? So let us first find dy by dt. So y is equal to 480, right? We mark this as equation 1. dy by dt, or let's write differentiate. So differentiate with respect to t. dy by dt is equal to 4a. Okay, this is your equation 2. Then let's put x equal to, so x is equal to 2at square, right? So dx by dt is equal to, dx by dt will be 4at. Okay, this is equation 3. Now therefore dy by dx will be equal to, what is dy by dt? It is 4a. Okay, and what is dx by dt? It is 4at. Okay, so let's cancel this out. So dy by dx is equal to 1 upon t. Mark this as equation 4. Okay, now to find d2y by dx square, you require the right hand side to be either in x or in y. So I'm going to put this t as a function of y, that is from equation 1. Okay, from equation 1, t is equal to y upon 4a. Okay, substituting in equation 4. So what will I write over here? Substituting in equation 4. Okay, so now when I substitute in equation 4, dy by dx is equal to 1 upon t, that is 1 upon y upon 4a, okay, which will be equal to 4a upon y. Now this is my dy by dx. Okay, what will we do now? We'll substitute, rather we'll say now again differentiate this function with respect to x, but I'm marking this as equation 5, and now I will differentiate with respect to Let's put this into blue, so you know that whenever the second order derivative is taken, it's in blue. So differentiate with respect to x. So d2y by dx square is equal to d by dx of, and bracket 4a upon y. Okay. Now in this 4a is a constant and y has to be differentiated with respect to x. Okay. So what we'll get d2y, we'll have d2y by dx square is equal to 4a outside common, and differentiation of 1 upon y minus 1 upon y square dy by dx. Okay. Now what all do we have to substitute here? Okay, to get the final answer, you have to remove y and you have to remove dy by dx. So dy by dx can be put in as 1 upon t from equation 4, and y can be put as 4at, right, from equation 1. So substituting, or you can say from equation 4 and equation 1. Okay, what are we substituting? Dy by dx and y square. So d2y by dx square is equal to 4a minus 4a, the minus sign I'm taking outside. Okay, so this is minus 4a bracket 1 upon, what is y from equation 1? It is 4at. So 4at the whole square multiplied by, what is dy by dx from equation 4? It is 1 upon t. Okay, so the final answer will be minus 4a upon 16a square t cube. A cancels, 4 ones are 4 fours are. So the answer is minus 1 upon 4a t cube. This is the second order derivative when you have parametric function. So any parametric function, when you take second derivative, you have to resubstitute from the previous, or from the question, or and the previous values. Okay, so that will give you the final answer. This was question 2, the second one. Let's move to the next one. Okay, so I'm doing question 2 now, the third one. Okay, question 2. Let's do the third one now. So third one is x is equal to sine theta, okay, and y is equal to sine cube theta. Again, they are parametric functions, that is, there is a parameter theta in it, okay, and you have to find d2y by dx when, or you have to find the value of d2y by dx when theta is equal to pi by 2. Okay, so let us begin. It is a similar kind of problem, that is, you have to use differentiation in the first one, then substitute the question again, and then take d2y by dx. So let's begin. We'll take the first function, x is equal to sine theta. Okay, differentiate with respect to theta. So we'll get dx by d theta is equal to, sine theta derivative is cos theta. Mark this as equation 1. Okay, then y is equal to sine cube theta. Okay, mark this as equation 2 because we require it for substitution. Okay, let's take dy by dx, or rather differentiate with respect to theta. So dy by d theta, one second, dy by d theta is equal to 3 sine square theta, right, and derivative of sine theta is cos theta. Okay, so 3 sin square theta cos theta. This is dy by d theta. We'll call this as equation 3. Let us write the equation for dy by dx. What it should be? Dy by dx will be equal to, by parametric theorem, or theorem on parametric functions, dy by d theta divided by dx by d theta. Right? So what is dy by d theta? It is 3 sin square theta cos theta. Okay, and divided by dx by d theta is cos theta. Right, so we'll cancel this out. We are left with 3 sin square theta. Okay, this is dy by dx. We'll mark this as an equation. We'll call it equation 4. Okay, now what did I say? When we have to do d2y, we need to express sin square theta in terms of x or y. So here I can write sin square theta as or rather you can put it over here, x is equal to sin theta. Okay, reason could be given, right? Therefore x square is equal to sin square theta. We'll put this in the above equation. Therefore dy by dx will be equal to 3x square. Okay, you can either substitute x or y. Now since I have sin square theta, so I'm using the x function. In the previous one I had used the y function. Okay, 3x square. Now d2y by dx square will become simple. So we'll write differentiate with respect to x in blue. So differentiate with respect to x again, that is second derivative. So d2y by dx square is equal to 6x, right? Resubstituting x. What will x be now? Sin theta. So therefore d2y by dx square is equal to 6 sin theta. In brackets you can write, since x is equal to sin theta, or you can number the equation and write that as the equation number. Okay, let's put in the value of theta now, because they've asked us to find d2y by dx square. Okay, at pi, or rather at theta equal to pi by 2. Okay, is equal to 6 sin pi by 2. What is sin pi by 2? Sin 90 is 1. So what is the value of d2y by dx square at theta equal to pi by 2? It is 6 at theta equal to pi by 2. Clear? This is how you would do the third question. Let's move on to the fourth one now. Yeah, the fourth question is x is equal to a cos theta and y is equal to b sin theta. So we have fourth question, x is equal to a cos theta, equation 1, and y is equal to b sin theta, equation 2. You have to find d2y by dx square at theta equal to pi by 4. Okay, let's begin. Again, same method it is, only some substitutions are different, so I am doing this also some for you. Okay, let's begin. So we have x equal to a cos theta. We've marked that as equation 1 already. Differentiate with respect to theta. So dx by d theta is equal to minus a sin theta. Right? Right. And y is equal to b sin theta, right? So dy by d theta is equal to b cos theta. Okay, now let us do dy by dx by parametric function. So dy by dx is equal to dy by d theta divided by dx by d theta, right? Okay. What is dy by d theta? B cos theta. And what is dx by d theta? It is minus a sin theta. Okay. Now let us substitute what is cos theta and sin theta, because we need to find the second order derivative, right? So from 1 and 2, we are going to remove this theta, eliminate the theta. So from equation 1 and 2, okay, right, dy by dx will be equal to minus b by a is a constant, leave it there. Cos theta is x upon a, right? So it will be x upon a square, and sin theta is y upon b, which will become b square upon y, reciprocal, right? So from equation 1 and 2, I have substituted cos theta and sin theta, okay? So that makes the equation minus b square a square x upon y. Okay, this will help me to find the second order derivative. Let us start with the second order derivative now. So differentiating again with respect to x, okay? dy by dx, or rather sorry, d2y by dx square now will be equal to minus b by a is a constant. Derivative of x upon y, we have to use the division rule. Okay, so d by dx of x upon y. Let us use the division rule. Minus b by a remains there in the bracket. Denominator square, denominator as it is, derivative of the numerator minus x, derivative of the denominator. dy by dx. Okay. Now what we'll do is we'll keep the y square, or rather we can keep the y square outside. We'll take it outside. Okay, so we'll get minus b upon a y square outside for now. First term is y minus x. What is dy by dx value? We'll substitute it from here, calling this as equation 3. So what is dy by dx? Minus b square x a square y. So minus b square x upon a square y. Okay. So what are we getting the final answer as? Let's check. d2y by dx square is equal to minus b ay square is already there. Open the bracket. Y is the first term plus x square b square plus x square b square divided by a square y. Okay, what we can do is we can put the b term inside. Okay, so one mistake that we've done is the constant term b square a square. So that's supposed to be b square upon a square. I'd written b by a by mistake. So b square a square, that has come here. Now what I'll do is only send the y square term inside. So d2y upon dx square is equal to the minus b square upon a square remains here only. And I'll send the y term inside, so this will be 1 upon y we are left with, plus, what's that, plus, yeah, plus x square as it is, b square upon a square and y cube. Okay, let's substitute what is x and y now. So we have minus b square upon a square as it is. Okay, what is y? From equation 2, it is b sine theta. Okay, plus what is x from here? It is a square cos square theta, because x square is asked. Okay, b square as it is, divided by a square. What is y cube? Y cube is b cube sine cube theta. Okay, so when I substitute here, you will write from equation 1 and 2. Okay, yes. Now what we'll do is, okay, here we can still simplify. A square cancels, b cancels, 1 upon b sine theta. Okay, so we have minus b square, minus b square upon a square. Okay, bracket 1 upon b sine theta over here. Okay, and plus cos square theta upon b sine cube theta, right? Yes. Now I can take b sine theta common. Okay, so I'm going to get minus b square upon a square b sine theta common. What am I left with over here? 1 upon 1 plus.
So what is cos square theta upon sine square theta? It is cot square theta. So minus b square upon a square. B cancels out here. So we're left with only 1b, right? So we have a square sine theta, okay, 1 plus cot square theta, okay. Now let us find the value of d2y by dx square, okay, at theta equal to pi by 4, okay. So what it will be, d2y by dx square is equal to minus b a square, right, sine theta, that is sine pi by 4, okay, bracket 1 plus cot square pi by 4. What is cot pi by 4? Cot 45, 1. So minus b upon a square, 1 by root 2, 1 plus 1, okay, which is minus b root 2 upon a square into 2. So your final answer is minus 2 root 2 b upon a square, okay.
Other sums from 1 and 2, you can let me know. I'll solve those for you too. Thank you very much.